Okay, moving on to the second part of our presentations today, and I apologize. I don't know why I have this taskbar down at the bottom, but hopefully that won't block us too much. Something doesn't look quite right. Okay. Okay. So we have just gone through the process of creating a scatter set that will inform the topobathymetric boundaries of our grid. We have an activity classification now. Now we're moving on to actually defining, I'm sorry, excuse me. Moving on to actually defining what are the cell size going to be across our domain. And we do that with the Quadtree generator tool. Sorry, excuse me. So on your own, or we can open up previously saved project from the directory. Your display may look a little different from what is shown on the screen. That's this blue note down here. And this little computer screen, we can click on that. That's our display options shortcut that will bring up different options for you to play around with. Okay, so great. What we're going to do now is, as we work on this Quadtree grid, we're going to bring in some imagery that will help inform some of our decision making. What is the water depth variable? How variable is that in the area that we're actively working in? So first we can bring in imagery, and that is available in the data that we provided. And setting the transparency of the display, excuse me, display options allows us to see both the topobathymetric variation in the scatter set, as well as the imagery. Another useful tool I use all the time is when I bring something in, I want to make sure it was brought into the right place, or just get a sense of the whole thing, is to use this zoom to extents feature button. And that is shown here. If you click on this one up at the top across the main toolbar, it'll show you your entire project within view. And you can also, I think, just simply right click one of these, and it will let you particularly zoom to the extent of just that feature. Okay. Additionally, we can bring in imagery dynamically with CMS. Okay, SMS, excuse me. So the way we do that is we see these different, looks like archetypal imagery types with a little plus sign, and that means add imagery. So we can click on that. Again, shown there, and that will bring up a myriad of options for us to see while we work in SMS. So for our purposes, we'll use world imagery, although you can really use whatever your preference is. And voila, we have that in our background now. Okay, now we're going to spend some time talking about Quadtree resolution areas. And this is one area that person can spend a lot of time going back and forth between produced grid and if we have to go back to the refinement, because we just don't have enough resolution in an area that gets running and drying, and we have stability issues. It's often that we have to go back to the resolution. So we do that dynamic or adaptive I would, maybe dynamic's not the right word because it doesn't happen on the fly, but that iterative process of resolution refinement happens in the Quadtree generator polygons. So the resolution for these telescoping grids, as we've just discussed, is happening with polygons. So the way we do that is we create these different polygons that we then can classify or set to have a particular maximum refinement. And what we often do is gradually transition the resolution from really fine where we really need it. So for example, close to the inlet here, right around this jetty, and then gradually increase the maximum cell size so that in the forcing end of the domain where we have really deep water, we don't need as much resolution. It's pretty well defined and stable, the transition between or the movement and change in wave and currents and tides at the open ocean. So we don't need as much resolution there. So an example of the final resolution map for the Shark River project is shown here. And each polygon has a different cell size specified. So once we've created these polygons, kind of like we did with the activity classification development, so similar process of creating these arcs with the vertices and nodes, and then turning them into future objects with polygons, we can right-click those, and this polygon attributes box comes up. So what we want to do is when we're defining these, we want to make sure to hit maximum grid cell size so that SMS doesn't try to coarsen things up, because by default, as a default, it's going to want to minimize the computational nodes and cells for a more efficient model, but it doesn't have the information that we do as the user to know, no, I really need you to keep high refinement here. So for example, this whole area that we've specified here is going to be 5 meters resolution, and that might be really small. So that's why we know it's important for the resolution to be really small there, but SMS might try to, by default, increase the resolution to something really large in that area. Okay, so when we're ready to try to build a grid, save the project first. And as I mentioned earlier, you may want to create a new project directory specifically for the next stage of the work so that you don't lose any of your previous work. Okay, once we've got our Quadtree polygons defined, we have told SMS, this is how I want the resolution to be distributed over the domain. What we can do is right-click in the data tree, the Quadtree generator feature, and hit convert, and then map to Quadtree grid. So that is going to bring up this box, which should be familiar. It's very similar to the Quadtree grid frame properties tool. So you can see it copied by default all of our information that we had set from the Quadtree generator grid frame, the origin position, the angle of the grid, the total width and height, or the X and Y total length. And then what we're doing here in INJ, now that we have some context and we've gone through the process of generating or defining what we want the resolution to be, we now know, based off of maybe you started at the smallest resolution very close to the inlet and worked your way outward, you have a sense of what approximately this outer bound resolution is going to be. So that's where you want to provide some information on the telescoping base cell size. So that's effectively going to be the largest size cell in your domain. So you don't want to set that to 1000 if you really want your grid cells to be out here no larger than 160 meters. So now that you've defined how you want the grid to be distributed, we now need to give it the actual values that it will use for the computational nodes and cells. And we do that through these depth options here. So the source is going to be our scatter set. And what we'll do is when we select that, it will give us an option to click which scatter set we want. So that's another reason why it can be useful to clean up your data tree so you don't accidentally click the right one. But once we do that and we say, these are the depths that I want you to take the information from and turn those into cells, we hit OK. And now we have some beautiful Quadtree grids. So you can see how the domain moves from these really large cells to very, very small cells. We can almost see how small they are because of the lines here. And recall that we set this activity classification because the Quadtree generator has no capability to quote to more or less turn itself off. We can't say don't have cells out here. So that's why we have to go through the process of the activity classification to say, even though there are computational cells here, we don't care about them, don't perform any computations here. What you can do is zoom around and look closer to the inlet and the other small, more challenging hydrodynamically complex features in your grid and make sure they're well resolved. You can also play with your display options to help with that. Some tips as you go through the telescoping grid development process. You want to have a transition of 2 to 4 cells per cell resolution change in any direction. So for example, the size of the cell here is going to dictate the size of the cell in the next smallest layer because it will be split in 4 because that's the nature of the Quadtree grid. In some cases, it's split in 2, which I don't know if you can really see that, but a function of 2 or 4 is something that we generally recommend because that's the nature of the grid, or rather the Quadtree grid type. Again, channels with substantial currents and large gradients in currents should be refined to at least 10 cells wide, and inlets may need to be closer to 20 cells at flow confluence points. Structures with variable morphology, like verbal mounds, may need extra resolution around the edges, and higher resolution areas may be necessary in areas of rapid wetting and drying and sediment transport, as we discussed earlier.